We have another example on the board. This problem is a little bit different. Why? Because we have given voltage and admittance, total admittance expressed in the rectangular form. So what you're supposed to understand from this notation that this is nothing else, just your conductance, G, and this is your capacitive susceptance, BC. The problem is asking me to find Z total, I total, and current through each branch. Okay, so what I'm supposed to do first, I'm going to find resistance. Okay, of course, there are many other ways to solve this problem, as I said, but let's do this way first. So I have resistance is equal 1 over conductance, where I have 1 over 2.5 millisiemens is equal 400 ohms. This is the value of my resistance. Next, I'm supposed to find the capacitive reactance. X of C is equal 1 over capacitive susceptance. So I have 1 divided by 4.2 millisiemens, and because I have J, I can add J over here or angle 90 degrees. I want to get my answer in polar form, that's why I'm going to get the angle. So I have X of C is equal 238.09 ohms and angle of negative 90 degrees. So I found the resistance and found the capacitive reactance. Next, we're supposed to find total impedance. Total impedance I'm going to find from the formula which we used before, called product over the sum. Why? Because I have two components connected in parallel and both values of the resistance and capacitive reactance I found, so I can use Z total is equal R times X of C over R plus X of C, which is equal 400 ohms times 238.09 ohms and angle of negative 90 degrees over 400 ohms plus 238.09 ohms and angle of negative 90 degrees. This is equal 204.59 ohms and angle of negative 59.23 degrees. Okay, this is the total impedance in my circuit. Next, I'm supposed to find I total. I total is equal voltage source over Z total. I'm using Ohm's law, where voltage source is equal 18 volts. Okay, because my voltage is expressed in terms of the sinusoidal equation, that's why this amplitude, right? I mean, this value represents my voltage peak. So I have Z total equals 204.59 ohms and angle of negative 59.23 degrees. Everything is equal 87.98 milliamps and angle of 59.23 degrees. Okay, so this is my total current. Next, I'm supposed to find the current which goes through the resistor and capacitor. Because these two components are in parallel, okay, I'm going to use Ohm's law, okay, and you have to keep in mind that the voltage source is equal voltage across the resistor, and this is also equal voltage across the capacitor. Everything is equal 18 volts. So I have IR is equal voltage across the resistor over resistance, where voltage across the resistor is equal 18 volts, we said up there, 18 volts over the resistance, which is equal 400 ohms. This is equal 45 milliamps. IC is equal voltage across the capacitor over X of C. So I have 18 volts divided by X of C, 238.09 ohms, and angle of negative 90 degrees. Okay, this is equal 75.6 milliamps and angle of 90 degrees. Okay, these are my currents. Next, we're supposed to verify if our answers are correct by using KCL, Kirchhoff current law, which says that I total is equal, in this case, the current which goes through the resistor plus the current which goes through the capacitor. So I have current which goes through the resistor is 45 milliamps plus the current which goes through the capacitor is equal 75.6 milliamps and angle of 90 degrees. So if I total is equal 87.98 milliamps and angle of 59.23 degrees. Next, you're supposed to verify this value, right? You're supposed to compare this value and this one, right? If both of them are the same or close to each other, means that up to this moment our calculations are fine. Next, we're supposed to find the capacitance of the capacitor in the parallel circuit. So in order to do so, I'm going to use the formula for the capacitive reactance. X of C is equal 1 over omega C. Why I'm using this time omega? Because omega is given. I have to solve this formula for C, for the capacitance. So I'm going to have C equals 1 divided by omega times X of C, which is equal 1 divided by omega 4 times 10 to the 6 radians per second times X of C, 238.09 ohms. This is equal 1.05 nanofarads. Okay, so this is the capacitance in the parallel circuit. Next, we're supposed to find the true power. P true is equal 1/2 VR to the second power over resistance. This is the formula for true power when we use voltage peak. Please notice that we have given voltage peak, okay? So this is parallel circuit. So voltage source in this case is going to be equal to what? Voltage across the resistor, and this is also equal to voltage across the capacitor. Everything is equal 18 volts. So I have 1/2 times 18 volts raised to the second power over the resistance, which is equal 400 ohms. This is equal 405 milliwatts. Okay, this is the true power in my circuit. Next, I'm supposed to find the reactive power. QC is equal 1/2 VC to the second power over X of C, which is equal 1/2 times 18 volts raised to the second power over X of C, which is equal 238.09 ohms, is equal 680.41 millivolt ampere reactive. Okay, so this is the reactive power in my circuit. Next, I'm supposed to find the apparent power. S is equal 1/2 voltage source raised to the second power over Z total, which is equal 1/2, and I have 18 volts raised to the second power over Z total, 204.59 ohms. Everything is equal 791.82 millivolt amp. Okay, this is the apparent power in my circuit. Next, I'm supposed to find the series equivalent circuit. So I'm supposed to copy down the total impedance. Z total is equal 204.59 ohms, and angle of negative 59.23 degrees. Okay, and convert this to the rectangular form. Rectangular form, okay? So you're supposed to obtain 104.66 ohms minus J 175.78 ohms, where the real part is my RS and the imaginary part is my X of CS. Okay, so this is the resistor and this is the capacitive reactance in my series circuit. Next, I'm supposed to find the capacitance in the series circuit. I'm going to use the formula for the capacitive reactance. So I have X of CS is equal 1 over omega CS. In order to find CS, you're supposed to solve this formula for CS. So if CS is equal 1 divided by omega X of CS, which is equal 1 divided by omega 4 times 10 to the 6th, of course radians per second, times x of CS, we found this is equal 175.78 ohms, close parenthesis. Okay, I'm going to write my result over here, okay? So I have CS is equal 1.42 nanofarads. Okay, so this is the capacitance in my series circuit. Next, we're supposed to draw the diagram. So let me draw the diagram over here. So I have resistor and I have capacitor, and of course I have a voltage source. So my voltage source is equal to 18 sine and omega times t, and resistance we found is equal 104.66 ohms, and capacitance is equal 1.42 nanofarads. Okay, so at this moment we can say that the problem is solved.